Hello and good afternoon, my dear kids. Welcome back once again to this short tutorial video for class 8 students under the topic factorization. Okay, it's been a while, isn't it? Okay, so before moving on to the topic factorization, I would like to tell you a few things regarding the topic. Okay, the first thing is that this term factorization, the topic that we are about to discuss or about to learn, comes under algebra. Okay, so that means the basics of algebra will be applicable here as well. So for those who haven't gone through the basics, please go through the basics first. Okay, otherwise the terms may be the terms that we use in the topic, you may not understand the terms. Okay, and the second thing, important thing is here is that since the topic contains factor, see, it's about factors, isn't it? The topic itself says factorization, so it's about factors. So in this one, what we'll be learning about the factors of algebraic expressions. Okay, not constant numbers or not arithmetic numbers. Okay, not constant numbers, that is not a constant or exact number, natural number or a whole number, but here we'll be dealing with the factors of algebraic expressions. Okay, so that means basically the answer, whatever we do in the factorization, basically the answer has to be in the product form, because it's about factors, isn't it? That's how we're supposed to find the factors of a constant numbers as well, isn't it? Okay, so your first topic we have for today is from exercise 14a, that is factorization of binomials. Okay, so the binomial, as we know, binomial, it's about two terms, isn't it? So the first question I picked here for today is that from question number 1, exercise 14a, question number 1. Okay, so we have here binomial as 3y minus 9. So see, we know the relation between a constant and a variable, that is, it's given as 3 and y, constant and a variable. We know the relation between them is multiplication, isn't it? So what I've done in the second step is that I have simply written it in the factor form. See, 3 and y, I have written it as 3 into y. For 9, it's not a prime number, so I have taken the prime factors of 9 as 3 into 3. Okay, I haven't changed anything, isn't it? Simple. From first the question to the second line, what I have done here in the second line is simply taken out the factors of the terms, the first term and the second term, though it's a binomial, isn't it? So 3 into y minus 3 into 3. Okay, so now what do I see here is the 3 from the first term and 3 from the second term. We got similar terms, isn't it? So what you can do here is, as you know, it's about factors of algebraic expression, as I've already mentioned, isn't it? So what we can do here is we can take these 3 as common. See, from the first term these 3, and from second term these 3 as common. I've marked it in circle as well, isn't it? So if you take common this 3 as common from first term and the second term, so what's left from the first term? See, y is left from the first term, isn't it? The sign remains same, minus, and 3 is left from the second term. So we need to keep that within the bracket because it's a binomial, remember, isn't it? So your answer is 3 bracket y minus 3. That's your answer. It's in the product form, isn't it? What does a bracket signify? Bracket signifies multiplication, isn't it? So it's in the product form, so we have the factors. So what we can say here is that the factors of 3y minus 9 is 3 bracket y minus 3. Okay, so this is how factorization is done. Okay, let's do a few more sums and it will be easier for you. Okay, the next question we have here is from question number 4. I have 5m plus 5n. So from the question to the second part, in the second line, what I have done here, say simple, I have written it in the single term, remember the first term and the second term of the binomial in the factors. I have expressed the terms first term and second term in its factors. See, 5 into m plus the sign remains the same, 5 into n. So again, what do I see? From the first term and the second term, I have 5 as common. So what can I do? I can take 5 as common, isn't it? So I have taken 5 as common, opened up a bracket. What's left from the first term? M, isn't it? The sign remains same as I said, plus, and what's left from the second term? N. So we got our answer as 5 bracket m plus n. It's in the factor form, isn't it? Because the bracket, it signifies multiplication. Okay, it's easy one, isn't it? So let's do a few more sums. Okay, Okay, for question number 7, question number 7, what we have here is minus 3m minus 15n. The first term of the binomial here has a negative term, as well as the second term is a negative term. So I've expressed first term as, see, minus 3 into m. That's what I can do, isn't it? As I know the relation between a constant and a variable, it's multiplication. Minus, for this 15, see, I've taken the prime factors of 15, so I've expressed it as 3 into 5 into n. Okay, I hope you understood this one. Simple. See, for 15, 3 into 5, I've expressed it in its factors, prime factors, 3 into 5 into n. N was already there. So what do I see here is that again we got 3 as the constant term 3 as common in both the terms, the first term and the second term, isn't it? In this kind of sums, what you can do here is, when we have both the terms with a negative sign, what you can do is you can take negative also as common. Remember, you can take sign also as common. So if I have taken minus 3 as common, what happens if you take sign as common is the sign will change of the terms. If you take sign common, remember, if you take sign as common, the sign of other terms will change. Like for example, in this one, when I have taken minus 3 as common, this m, now it went inside the bracket. So what is the sign of m now? It's a positive m, isn't it? Outside the bracket it was negative, isn't it? Inside it became positive. See, similarly this sign minus will turn to positive inside the bracket, and what's left from the second term? 5 and n, so 5n in here. Okay, so finally what do I got here? Minus 3 bracket m plus n. Within the brackets we got binomial, two unlike terms. We cannot do anything regarding it, isn't it? The answer we got here as minus 3 bracket m plus 5n in its factor form. So we are done here. Okay, let's go to the next question. So the next question we have here is 6x squared minus 11x. So again, for the first term of the binomial, I've expressed in its prime factors. See, 2 into 3 x squared, as we know, we can write it as x into x, isn't it? Minus 11, it's a prime number, so 11 into x. What do I see here? For the first term and the second term, I've got just a variable as a common term. See, you can take, remember, you can take variables also as common. Okay, so I've marked it as within the circles. I've marked the common terms within the circles. So x in x is common, so I've taken x as common. So now what's left from the first term? 2 into 3, that is 6, isn't it? 6, and this x minus 11. The sign doesn't changes here. Why the sign doesn't changes here? Because we haven't taken the negative as common. Remember that. Okay, the sign only changes when we take negative also as common. Okay, so we have got factors of 6x squared minus 11x as x within bracket 6x minus 11. That's it. Okay, moving on to the next one. Okay, for question number 11, we got, see here what do we have? We got variables, isn't it? No, again we got a binomial, but this time what do I have is just in terms of binomial, in terms of variables. See, ax plus bx, isn't it? So for the first term of the binomial, I have written it, expressed it in terms of its factors as a into x. I know the relation between the two variables is also multiplication, so that's why I have written a into x. See, the sign plus remained as it is. Bx, I have expressed it in terms of its factors, b into x. Okay, so now from the first term and the second term, what's common? So I have, as you can see here, x is common, isn't it? So I have marked it circular. Okay, within the circles. And remember, you don't need to mark the common terms in circles and all in your exercise. Okay, I'm just marking it in order to show you. Okay, so x is common, so I've taken x is common. What's left from the first term? A. The sign doesn't changes here because we haven't taken negative as common, remember. So plus, what's left from the second term? B. So the factors of ax plus bx is x within bracket a plus b. Okay, moving on to the next question. What we have here is, again we got binomial, but in terms of variables. Again, x squared y plus xy squared. So I have expressed the variables, the terms in its factorial form, its factors, isn't it? So for x square y, I have written, for x square I can write x into x, isn't it? Into y, I know the relation between the variables is also multiplication, the same things, isn't it? Plus x, and for y square I have written y into y. So what's common? See, from the first term x, and the second term also we have x. In the first term also we got x, second term also, so I can take x as common. Similarly, what do I see here is, and remember one thing, yeah, we can take more than one common as well. Okay, so what do I see here? I see y also, y on the second term as well, y on the first term as well. So I've taken x, y as common. So if you take x and y as common, so what's left from the first term? X, simple. The sign doesn't change here as well, plus. So what's left from the second term? Y. So our answer is xy within bracket x plus y. Okay. I hope now you kids are getting a bit about the sums, isn't it? Okay. Now in question number 13, what do I have is, I got a constant term, that is 4, plus a constant with a variable, that is 12x square. A binomial though, isn't it? So again, the constant term 4, it can be expressed in its factors as 2 into 2, isn't it? Plus, and 12, the second term, we got a constant term 12, it can be expressed as 2 into 2 into 3 in its prime factors, isn't it? X square, for x square I have written x into x. So what do I see here is the first term. What do I see from the first term and the second term is that I have got 2 as common from both the terms. Again, second 2 also as common from both the terms. So I can take 2 into 2 as common, isn't it? If I write 2 into 2 outside, what will it be? It will be simple 4, isn't it? That's why I have directly written 4 out here. Okay, so 4. Now see, I have taken both the terms from the first term as common. So what's left from the first term? It's not 0, remember. There will always be 1. Okay, so because we can just simply write into 1 as well, isn't it? Into 1 doesn't change the value, isn't it? So therefore, from the first term, 1 left, plus remain as it is. From the second term, I got 3 as constant term, and both the variables left, that is x into x and x squared. So that's our answer. Okay. Okay. Moving on to the next one, we have here for question number 16. What do I have is, I got both in terms of variables, that is x square y square plus x square. Okay. So again, the variables I have expressed it in terms of its factors. For x square I have written x into x. For y square I have written y into y. See, plus second term I have got x squared, again x and x. So what do I see from the first term and the second term? I got both the x's as common. See, so that is why x into x. If I take x into x, what will it be? X squared, isn't it? So that is why I have written x squared out here. From the first term, what's left from the first term? Y and y. So it is y squared. What's left within the bracket? What's left from the first term? Y into y. So y squared out here. Plus, the sign doesn't change, so plus. So both the terms from the second term went to common, isn't it? So what's left here? As I already said, it's not 0, so 1 will always remain, isn't it? Because we can write into 1 out here, isn't it? Because whenever you multiply anything with 1, the value remains same, it doesn't change its value, so therefore 1 remains. Okay, so plus 1 out here. Okay. Okay. Okay, now the next thing that we'll do is factorization of trinomials. Now trinomials means 3 terms, isn't it? So let's go with the factorization of trinomials. So for question number 14, what we have here is, we got ax plus ay plus az. Now the first term of the trinomial I have expressed in terms of factors. See, a into x, second term as well a into y, third term as well a into z. What do I see? I see a as common from all the 3 terms. See, first term, second term and third term. I have marked it within the circle, isn't it? So if I take a as common from all the 3 terms, what's left from the first term? X. What's left from second term? Y. What's left from the z? Third term? Z. Isn't it? The sign doesn't changes because we haven't taken a negative as common. Okay. So therefore, the answer is a within bracket x plus y plus z. Okay. And question number 17. Moving on to the next question we have here is, again we got a trinomial. So we have question as p square minus 3pq plus pq square. Again I have expressed all the terms in its factors. For p square I have written p into p. See, for the second term, that is 3pq, I have written 3 into p into q, because I know the relation between the constant and the variables is multiplication. These are all we have done in basics, isn't it? For pq squared, I have written p into q. So what do I see here again? From first term, second term and third term, I have p as common. So that is why I have taken p outside the bracket. See, p as common. Then opened up the bracket. The first term, p minus, the sign remains as it is, minus what's left from the second term, p. It went to the common section, remember. So 3 into q, so 3q. Plus, again, this p also went to the common section. So what's left? Q into q, so q square out here. Okay, so here we are done with the sum. Okay, so and finally the last question for today. So again, we got a trinomial, and we have here 12p to the power 5 plus 16p to the power 4 minus 20p to the power 3. Okay, so again, for the constant terms, that is for 12, I have taken the prime factors of 12 as 2 into 2 into 3 into p to the power 5. It can be expressed as p into p into p into p into p 5 times, isn't it? Plus again 16, for the constant term 16 also I have expressed it in terms of its factors. See, prime factors 2 into 2 into 2 into 2. P to the power 4 means there will be 4 p's, so p into p into p into p. See, and finally comes the third term, that is 20p cube. So for 20p cube also I have expressed it in terms of its factors, that is 2 into 2 into 5, and for p cube I can write p 3 times, so p into p into p. Okay, now what do I see here? So from all the three terms, what do I see? I see 2 as common from all the three terms. Again, a second 2 is also common from all the three terms. So if I take 2 into 2 as common, what should I take? What can I take as common? 2 into 2 means 4, isn't it? I can take 4 as common, so that's why I have taken 4 as common. See, and for p also, see, 1p as common. The second p also common. Third p also common from all the three terms. So I can take p into p as also as common. So p into p into p will give you p to the power 3, isn't it? So that is why p to the power 3. Now, taking 4p cube as common. So what's left from the first term? 3p into p, that is p square. See, the sign remains same, plus, see, what's left? 2 into 2 is 4, we know. So 4. One of the p is left from the second term, so 4p. Okay, the sign again, the third term, minus. So what's left from the third term? It's just 5, isn't it? So 5. Okay, so that is how it is done. Okay, I hope you kids have understood. Okay, so what I want you to do is please practice the remaining sums from this exercise. It's an easy one. Okay, so, and let me know whether if you have any difficulty understanding the sum, please do let me know. Okay, till then, stay tuned, stay safe, bye bye.